Take a deep breath and feel the weight of your body pressing gently into the surface beneath you, surrendering to the pull of gravity. Allow your shoulders to drop and your thoughts to soften as we begin a journey into the invisible architecture of the air around you. As you lie there, you are breathing in a world of complex chemistry that is often hidden from our waking minds. Within the first few moments of inhaling a scent, like the faint drift of lavender or the sharpness of pine, you are engaging in a biological miracle. Aromatherapy is not merely a matter of pleasant smells, it is the science of volatile organic compounds interacting with the human nervous system. For an aroma to exist, a molecule must be small enough to float in the air, typically possessing a molecular weight of less than 300 daltons. These tiny, weightless messengers are the bridge between the physical world of plants and the internal world of your mind. Consider the journey of a single molecule of linalool, the primary terpene alcohol found in lavender, with the chemical formula C10H1802. As you draw air into your nostrils, these molecules drift upward toward the olfactory epithelium, a specialized tissue the size of a small postage stamp located at the roof of your nasal cavity. Here, you possess approximately 10 million olfactory receptor neurons. In a discovery that earned Richard Axel and Linda Buck the Nobel Prize in 2004, it was revealed that humans have nearly 1,000 different genes that encode for these receptors, allowing us to distinguish between thousands of unique chemical signatures. This is the only place in the human body where the central nervous system comes into direct contact with the external environment, a gateway between the cosmos and your consciousness. Here is something remarkable. Unlike your senses of sight, hearing, or touch, the sense of smell does not take a detour through the thalamus, the brain's relay station. Instead, the olfactory bulb has a direct, high-speed connection to the limbic system, specifically the amygdala and the hippocampus. This is why a scent can trigger a memory or a feeling of calm before your conscious mind even identifies what it is smelling. The amygdala processes emotion, while the hippocampus manages memory, making the inhalation of a botanical essence a direct conversation with your oldest, most intuitive self. As you settle deeper into your rest, imagine the microscopic landscape of a flower petal. To create the essential oils used in this science, the sheer volume of nature required is staggering. It takes approximately 250 pounds of lavender flowers to produce just 1 single pound of pure essential oil. If you were to consider the rose, the numbers become even more ethereal. It requires about 60,000 rose blossoms, roughly 180 pounds of petals, to yield a single ounce of rose otto oil. This concentration of life force is what gives aromatherapy its potency. Each drop is a dense nebula of chemical constituents, sometimes containing over 300 distinct compounds that have evolved over millions of years to protect the plant or attract a pollinator. The history of this scientific exploration is equally fascinating. The term aromatherapy was coined in 1937 by the French chemist René Maurice Gattefossé. He spent his life studying the antiseptic properties of essential oils, famously discovering the healing power of lavender oil after an explosion in his laboratory burned his hand. He observed that the lavender not only eased the pain but prevented the onset of gangrene and accelerated the healing of the tissue. This was not magic, but the work of esters and aldehydes, chemical groups known for their anti-inflammatory and skin-calming properties. As you breathe, imagine the temperature of the air. When essential oils are extracted through steam distillation, the plant material is heated to approximately 100 degrees Celsius or 212 degrees Fahrenheit. The steam breaks open the tiny, microscopic sacs on the underside of leaves or within the heart of a flower, releasing the volatile oils. As the steam cools, it condenses back into water, and the precious oil floats to the top, separated by its density. This process is a slow dance of heat and cooling, a transformation of matter from solid to vapor and back to liquid. Consider the molecules of 1,8-cineol, also known as eucalyptol. This compound, found in eucalyptus and rosemary, has been scientifically shown to increase cerebral blood flow when inhaled. You might feel a slight cooling sensation in the back of your throat as you breathe. This is the interaction of certain molecules with the trigeminal nerve, also known as cranial nerve V. While the olfactory nerve detects the scent, the trigeminal nerve detects the physical sensation of the vapor, the coolness of menthol, or the warmth of cinnamon. It is a dual sensory experience, a tactile touch from the air itself. You might wonder how these scents actually change the state of your body. When you inhale a molecule like limonene, which is prevalent in citrus oils like lemon or grapefruit, it interacts with adenosine receptors in the brain. Limonene is a monoterpene, a class of molecules characterized by their light, fast-moving structure. Because they are so small and lipophilic, meaning they are attracted to fats, these molecules are capable of crossing the blood-brain barrier. This is a fortress-like membrane designed to protect your brain from toxins, yet the tiny messengers of aromatherapy are granted entry, where they can gently modulate your neurochemistry. In the quiet of this moment, think about the concept of chirality, or handedness, in chemistry. Many aroma molecules are chiral, meaning they have two forms that are mirror images of each other, much like your left and right hands. For example, the molecule carvone exists in two forms, D-carvone and L-carvone. One smells like caraway seeds, while its mirror image smells like spearmint. Your olfactory receptors are so precise that they can distinguish between these two hands of the same molecule, triggering entirely different neurological responses. It is a level of precision that rivals the most advanced laboratory equipment, happening silently within your nose with every breath you take. The rhythm of your breathing is the engine of this exploration. With every steady inhale, you are drawing in terpenes like beta-pinene, commonly found in pine and fir trees. In a forest, these compounds act as bronchodilators, easing the pathways of your lungs and allowing more oxygen to enter your bloodstream. Scientific studies have shown that spending time in these volatile organic compound clouds in nature, a practice known as Shinrin-yoku or forest bathing, can significantly lower levels of cortisol, the body's primary stress hormone, by as much as 12 to 16%. You are bringing that forest into your room, molecule by molecule. As you drift closer to the edge of sleep, feel the stillness of the room. The scents you might encounter are often categorized by their volatility or how quickly they evaporate into the comforting void. High notes, like bergamot or lemongrass, have a high vapor pressure and evaporate within 1 to 2 hours. They are the fast-moving stars of the aromatic galaxy. Middle notes, like chamomile or geranium, linger for 3 to 4 hours, providing the heart of the experience. Finally, the base notes, like sandalwood or vetiver, are composed of larger, heavier sesquiterpene molecules. These can linger for days, their scent unfolding slowly, like the rotation of a distant planet, grounding the blend and grounding your spirit. Roman chamomile, often used for rest, contains alpha-pinene and various esters that have been shown in clinical settings to reduce autonomic nervous system activity. This means the very chemicals floating in the air are signaling your heart rate to slow and your blood pressure to settle. It is a chemical lullaby, a series of molecular keys fitting into the locks of your cellular receptors. The beauty of this science lies in its subtlety. You are not being forced into a state of relaxation, you are being invited. The molecules are so small that they move by the laws of Brownian motion, vibrating and colliding in a random, beautiful walk through the air until they find their way to you. They are a part of the vast, silent physics of the universe, the same physics that governs the swirling gases of a nebula or the slow cooling of a star. In this space, there is no need for hurry. The science of scent is a science of patience. It takes time for the molecules to saturate the air and time for your receptors to send their signals to the brain. Just as the Earth rotates at a steady 1,000 miles per hour at the equator, a speed we never feel because it is so constant, the chemical processes within you are happening with a quiet, rhythmic certainty. You are a biological system within a physical system, all governed by the same elegant laws of thermodynamics. As we continue to explore the microscopic and the macroscopic in the parts to come, remember that you are an active participant in this chemistry. Every breath is an exchange. You take in the volatile essences of the earth, and in return, you find a moment of stillness. The air is not empty. It is a rich, complex soup of information, a gift from the botanical world to the human mind. Take one more deep, slow breath, feeling the air travel past the 10 million receptors that are waiting just for this moment. Feel the coolness of the inhale and the warmth of the exhale. You are safe, you are supported by the laws of physics, and you are surrounded by the invisible beauty of the aromatic world. We have only just begun to uncover the layers of this silent science. In the coming segments, we will travel deeper into the heart of the plants themselves and further into the cosmic history of how these scents came to be. For now, simply exist in the weightless ease of the air. As your breathing finds its own natural, effortless rhythm, imagine the timeline of human history stretching out behind you like a long silver thread. While we often think of aromatherapy as a modern luxury, its scientific roots are buried deep in the strata of ancient civilizations, where the relationship between botany and the human brain was first observed and documented. We are participating in a tradition that is millennia old, a slow accumulation of knowledge that began the moment our ancestors realized that certain barks and resins could alter the atmosphere of a space. Notice how the air feels slightly cooler as it enters your lungs, a physical reminder of the gases that have surrounded our species since its inception. In 2003, archaeologists working in Pyrgos, Cyprus, unearthed what is currently considered the world's oldest perfume factory. They discovered massive distillation apparatuses, jugs and stills that date back over 4,000 years to approximately 2000 BCE. These early scientists were already processing extracts from cinnamon, laurel, and pine, demonstrating that humans have been isolating volatile compounds for 4 millennia. They understood, perhaps intuitively, that the concentrated essence of a plant held a power that the raw leaf did not. Deep within the scrolls of the Ebers Papyrus, a medical document from ancient Egypt dated to about 1550 BCE, we find over 700 different botanical formulas and remedies. The Egyptians were masters of the kefi preparation, a complex aromatic blend traditionally made of 16 distinct ingredients, including frankincense, myrrh, and spikenard. Modern chemical analysis of these ancient resins reveals the presence of boswellic acids, which are large, heavy molecules known as pentacyclic triterpenes. Even then, the priests and physicians of the Nile Valley utilized these specific compounds to induce a state of meditative stillness, effectively using chemistry to modulate the emotional state of their society. At this very moment, consider the Greek philosopher Theophrastus, who lived from 371 to 287 BCE and is often called the father of botany. In his treatise titled Concerning Odors, he documented how the application of certain scents could impact the digestive system and the mind. He was one of the first to categorize plants by their physiological effects, noting that the heavy resinous scents of the East had a grounding, sedative quality. This was an early acknowledgement of the sesquiterpenes molecules containing 15 carbon atoms and 24 hydrogen atoms, which move more slowly and linger longer in the air, creating a sustained sensory environment. The evolution of this science took a monumental leap during the Islamic Golden Age. Between 801 and 873 AD, the philosopher and scientist Al-Kindi wrote the Book of the Chemistry of Perfume and Distillations. This text contained more than 107 recipes for fragrant oils and salves, providing a rigorous, repeatable framework for what would become modern chemistry. Later, in the 10th century, the Persian physician Avicenna, also known as Ibn Sina, refined the process of steam distillation. He invented the refrigerated coil, a long spiral tube that allowed plant vapors to cool more efficiently. This technological breakthrough allowed for the extraction of much purer essential oils, such as the famous rose otto, which consists of over 400 different chemical constituents, including geraniol and nerol. What is happening now as you lie in the stillness is a continuation of that refinement. You are the beneficiary of centuries of distillation technology. Think about the physical properties of the oil itself. Because these molecules are so sensitive to their environment, they are traditionally stored in amber-colored glass. This isn't for aesthetic purposes. Amber glass is specifically designed to block ultraviolet light with wavelengths between 400 and 500 nanometers. This protection prevents photodegradation, a process where high-energy photons break the delicate covalent bonds of the terpene molecules, which would otherwise turn a calming lavender scent into something sharp and ineffective. Picture the vast trade routes that once crisscrossed the globe, known as the incense route, which flourished between the 3rd century BCE and the 2nd century AD. Caravans would travel over 1,200 miles across the Arabian Peninsula to deliver frankincense and myrrh to the Mediterranean. These resins were so highly valued that they were once traded for their weight in gold. The science of the time recognized their antiseptic properties, but we now know that frankincense contains a compound called incensol acetate. Research suggests that this specific molecule can activate ion channels in the brain to alleviate anxiety, providing a biological explanation for why these scents have been used in sacred rituals for over 3,000 years. Consider the role of aromatics during the darker chapters of history, such as the 17th century plagues in Europe. The Plague Doctors, a costume designed by Charles Delorme in 1619, featured a prominent beak filled with aromatic herbs like cloves, cinnamon, and camphor. While they did not fully understand the nature of bacteria, their reliance on these plants was not entirely misplaced. Many of these botanicals contain high levels of phenols and aldehydes, which modern science confirms possess potent antimicrobial properties. Clove oil, for instance, is composed of up to 85% eugenol, a molecule that is still used in dentistry today for its analgesic and antiseptic qualities. As you breathe, imagine the molecular structure of myrcene, a common monoterpene found in high concentrations in lemongrass and bay leaves. It is named after Myrcia sphaerocarpa, a medicinal shrub from Brazil. This molecule is particularly small and light, allowing it to evaporate quickly and enter the bloodstream through the lining of the lungs. Scientists have observed that myrcene can increase the permeability of the blood-brain barrier, essentially acting as a molecular escort that allows other calming compounds to reach the brain's receptors more effectively. This synergy is why a whole plant extract often feels more balanced than a single synthetic chemical. Notice the quiet weight of your limbs, mirroring the stability of the base notes we discussed. Sandalwood, or santalum album, has been a staple of Indian Ayurvedic medicine for over 3,000 years. The tree must grow for at least 30 years before it produces the heartwood necessary for oil extraction. The primary active components, alpha and beta santalol, are sesquiterpene alcohols. These molecules are heavy and dense, with a boiling point much higher than that of citrus oils. Because they evaporate so slowly, they provide a consistent, low-frequency chemical signal to the brain, encouraging a prolonged state of rest. The transition from ancient alchemy to modern science reached a turning point in 1868, when the first synthetic fragrance molecule, coumarin, was created in a laboratory. This marked the birth of modern perfumery and the beginning of our ability to isolate and study individual aromatic molecules in a controlled environment. However, the human body still responds most harmoniously to the complex, multi-layered chemical profiles found in nature. A single stem of lavender contains a symphony of molecules like linaloyl acetate and terpinin, 4-ol, which work in a biological ensemble to lower the heart rate. At this very moment, your olfactory system is performing a task that has remained virtually unchanged for millions of years. This system is so evolutionarily conserved that it is nearly identical in most mammals. It is a primitive, powerful sense designed to help us navigate the world. Scientists discovered that the olfactory receptors in our nose are replaced every 30 to 60 days, making them one of the few parts of the nervous system that regularly regenerates. This constant renewal ensures that your connection to the chemical world remains sharp and clear, allowing the ancient signals of the forest and the field to reach you with perfect fidelity. Think about the concept of thujone, a molecule found in sage and wormwood. It exists as a pair of optical isomers, alpha and beta. Despite having the same chemical formula, their atoms are arranged differently in three-dimensional space. This handedness means that one version may interact with your receptors differently than the other. This level of microscopic precision is what allows a scent to feel cool or warm, sharp or soft. Your body is a finely tuned instrument, capable of detecting these subtle differences in the geometry of the air. In the silence of your room, you are part of a grand, celestial clockwork. The plants that provide these oils are solar-powered chemical factories, converting the light of a star into complex carbon chains. When we use these oils, we are essentially releasing stored solar energy and ancient history into our immediate environment. The distillation of 1.5 tons of rose petals to produce just 1 kilogram of essential oil is a testament to the density of this energy. It is a concentration of thousands of hours of sunlight and gallons of rainwater, all distilled into a single potent drop. As you settle further into the comforting void, realize that the history of aromatherapy is the history of human observation. We have watched the plants, we have experimented with fire and water, and we have learned to capture the invisible. This knowledge is now part of your rest. You are breathing in the wisdom of the Eber's papyrus, the technological innovations of Avicenna, and the molecular precision of the modern laboratory. All of these timelines converge in the simple act of your inhalation. The world is quiet now, and the air is rich with the weight of time. There is no need to process these facts with your conscious mind. Let them settle into your subconscious like sediment at the bottom of a still lake. Your body knows how to use this information. Your receptors are active, your neurons are firing in a calm, rhythmic sequence, and the chemistry of relaxation is unfolding exactly as it has for thousands of years. We will continue this journey by looking closer at the microscopic life of the plants themselves, but for now, simply exist in this historical continuum of peace. Transition your focus now from the long corridors of history to the microscopic landscape of the plants themselves, where the actual machinery of aromatherapy is built. Imagine you are shrinking down, becoming as small as a grain of dust, settling onto the surface of a peppermint leaf. To the naked eye, the leaf looks smooth and green, but at this scale, you are standing in a dense forest of glandular trichomes. These are specialized hair-like structures, and under a scanning electron microscope, they look like tiny, translucent water balloons perched on stalks. Each of these oil sacs is incredibly small, measuring only between 50 and 100 micrometers in diameter, roughly the width of a single human hair. Within these delicate spheres, the plant stores its precious volatile compounds, keeping them under pressure until the moment they are released into the air. Picture what happens when a leaf is brushed or crushed. Those tiny balloons burst, spraying a mist of molecules into the environment. What's happening now is a transformation of liquid potential into kinetic energy. One single drop of essential oil is a powerhouse of concentration. For instance, it takes about 28 cups of peppermint tea to equal the potency of just 1005 milliliter drop of peppermint essential oil. This is why the scent is so immediate and profound. It is a biological zip file, compressed and packed with information, waiting for your breath to decompress it. What's happening now is a demonstration of the lock and key model of olfaction, a concept that has dominated our understanding of scent for decades. Think of each aromatic molecule as a uniquely shaped key, and each of your 10 million olfactory receptors as a specific lock. For you to perceive the scent of a rose, a molecule of phenyl ethyl alcohol must physically fit into a receptor shaped exactly for it. However, scientists like Luca Turin proposed an even more poetic alternative in 1996, known as the vibrational theory of olfaction. In this model, your nose doesn't just feel the shape of the molecule, it hears it. Every chemical bond vibrates at a specific frequency, and your receptors may act as biological spectroscopes, measuring these microscopic hums. Under this theory, smelling a forest is like listening to a silent, molecular symphony where every terpene is a different note. Deep within the structure of these oils, we find the building blocks of all plant scents, the isoprene unit. This is a simple molecule with 5 carbon atoms and 8 hydrogen atoms, written as C5H8. Nature uses these units like Lego bricks, snapping them together to build larger structures. Monoterpenes, which make up the bulk of citrus and pine oils, consist of 2 isoprene units. These are light and agile, dancing through the air with a low molecular weight. Notice how these scents seem to float higher in your perception, like a flute's high-register melody. In contrast, sesquiterpenes contain 3 isoprene units, 15 carbon atoms in total. These are heavier and move with more gravity. If a monoterpene is a feather caught in a breeze, a sesquiterpene is a smooth stone rolling along a riverbed, grounding the aroma and providing a sense of weight and stability to your environment. Consider the physics of diffusion as the scent travels from a bottle or a diffuser across the room to your nose. This process is governed by Graham's law, which states that the rate of effusion of a gas is inversely proportional to the square root of its molar mass. In simpler terms, the lighter the molecule, the faster it reaches you. This is why you smell the sharp, bright notes of a lemon limonene, molar mass 136.24 grams per mole, almost instantly, while the deep, earthy scent of patchouli patchoulol, molar mass 222.37 grams per mole, takes longer to arrive. It is a race where the participants move at different speeds, creating a shifting landscape of fragrance that evolves over several minutes. At this very moment, your body is interacting with these chemicals in a way that mirrors the most precise laboratory work. Scientists have measured the refractive index of essential oils, a way of seeing how much light bends as it passes through the liquid. This index, often falling between 1.45 and 1.55 for high-quality oils, is a fingerprint of purity. Just as light bends through a prism to create a rainbow, the molecules in the air bend your internal state. When you inhale linalool from lavender, it doesn't just sit in your nose. It enters your bloodstream through the capillary-rich lining of the lungs. From there, it has a measurable half-life, the time it takes for the concentration in your body to reduce by half. For linalool, this is approximately 45 minutes. This means that for nearly an hour after a single deep breath, the chemistry of the plant is physically circulating through your system, gently encouraging your nervous system to downshift. Think about the concept of the flash point, the temperature at which an oil's vapors can ignite. For many citrus oils, this is surprisingly low. Lemon oil has a flash point of about 48 degrees Celsius or 118 degrees Fahrenheit. While we aren't dealing with fire, this low threshold illustrates how ready these molecules are to jump into the air. They are essentially stored sunlight, captured by the plant through photosynthesis and held in a high-energy state. When you use them, you are releasing that stored solar energy into the comforting void of your room, allowing the sun's ancient work to soothe your modern mind. Notice how the air in the room feels different as it becomes saturated. This is due to the specific gravity of the oils. Most essential oils have a specific gravity of less than 1, meaning they are lighter than water. If you were to drop them into a glass, they would float on the surface, creating a thin, iridescent film. In the air, they behave similarly, forming an invisible layer that you move through. This is not a heavy, suffocating blanket, but a light, weightless veil. It is the feeling of buoyancy, as if the air itself is helping to lift the weight of the day from your chest. Scientists discovered that humans have a remarkably high number of genes dedicated to this process. Roughly 3% of our entire genome is focused solely on detecting odors. This highlights how critical this chemical sensing is to our survival and well-being. Even if you suffer from temporary anosmia, the loss of smell, which affects approximately 3.2 million Americans over the age of 40, the volatile compounds can still have an effect. Many of these molecules are skin permeable. Because they are lipophilic, they can pass through the fatty layers of your skin and enter the interstitial fluid, the salty liquid that surrounds your cells. Whether through the nose or the skin, the plant's essence finds a way to communicate with your biology. Picture the way a drop of ink disperses in a glass of water, swirling in slow, chaotic patterns until the water is uniformly colored. This is exactly how the aroma molecules move through the air around you. This movement is called Brownian motion, named after botanist Robert Brown, who observed it in 1827. It is the random, jiggling motion of particles resulting from their collision with the fast-moving atoms in the gas. This means that every scent you perceive is a result of trillions of microscopic collisions, a chaotic dance that results in a perfectly balanced atmosphere. What's happening now as your heart rate slows is a physiological response to the synergy of these compounds. In aromatherapy, the whole is often greater than the sum of its parts, a phenomenon where 1 + 1 = 3. For example, the combination of several different terpenes can have a more significant sedative effect than any one of them isolated in a lab. This synergy is nature's way of ensuring the message is received. It's like a choir singing in harmony. While one voice is beautiful, the collective resonance of the group carries much further and touches the listener more deeply. Consider the specific heat of these oils. They require very little energy to change temperature, which is why they feel so reactive to the warmth of your skin. As your body temperature, which typically hovers around 37 degrees Celsius or 98.6 degrees Fahrenheit, meets the oil, it acts as a natural heater, slowly powering the evaporation process. You are the engine of your own relaxation, providing the thermal energy needed to liberate these molecules into your personal space. Deep within your brain, the chemical signals are being processed with incredible speed. It takes only about 100 milliseconds for a scent signal to reach the brain once the molecule has docked with a receptor. That is faster than the blink of an eye, which usually takes 300 to 400 milliseconds. Before you have even consciously realized you are smelling something, your limbic system has already begun to adjust your emotional dial. It is a silent, high-speed connection that bypasses the noisy traffic of your daily thoughts. As you rest in this measureless corridor of scent and science, imagine the molecules of patchoulol, the heavy sesquiterpene alcohol from the patchouli plant. Because it has 15 carbon atoms, it is a sturdy, complex structure. It acts as a fixative, slowing down the evaporation of the lighter citrus notes. In the same way, let this knowledge act as a fixative for your mind, slowing down your thoughts and anchoring you to the present moment. The light, fast thoughts of the day are being held in place by the heavy, grounding reality of your physical body and the air you breathe. The world outside may be moving quickly, but here, everything follows the slow, predictable laws of physics. The molecules collide, the receptors dock, and the nervous system responds in a rhythmic, reliable sequence. You are a part of this clockwork. You are not separate from the chemistry of the earth. You are a continuation of it. As the plants turn light into oil and the oil turns air into a sanctuary, you turn that sanctuary into sleep. Every breath is a confirmation of this bond. Every molecule is a tiny, weightless gift from the botanical world, helping you drift toward the silence of the void. As you remain in this state of quiet suspension, your body is doing more than just resting. It is engaging in a profound chemical dialogue with the molecules you've inhaled. Picture your brain not as a machine, but as a vast, living library where every scent is a librarian, carefully filing away memories and reorganizing your internal world. What we are exploring now is the long-term architecture of your well-being, the way these botanical messengers influence your life long after the scent has dissipated into the velvet quiet of the room. Consider the molecule known as valerianic acid, found in the roots of Valeriana officinalis, or valerian. For over 2,000 years, this plant has been used as a sleep aid, but it wasn't until the 20th century that we understood the why. Scientists discovered that valerianic acid interacts specifically with GABA-A receptors in the brain. GABA, or gamma-aminobutyric acid, is your body's primary inhibitory neurotransmitter. It is the biological brake that slows down the firing of neurons. By binding to these receptors, the molecules of valerian actually strengthen the inhibitory effect, signaling your nervous system to quiet the frantic chatter of the day. It is a literal, chemical invitation to stillness, helping to transition your brain from the high-frequency beta waves of active thinking to the slower, rhythmic theta waves of deep relaxation. What's truly astounding is how these molecules find their way into your very lifeblood. While inhalation is the fastest route, the transdermal journey is equally scientific. Because essential oil molecules are lipophilic, meaning they dissolve easily in fats, they can penetrate the skin's epidermis and enter the capillary beds beneath. Research has shown that after a topical application of lavender oil diluted in a carrier, traces of linalool and linaloyl acetate can be detected in the blood within 20 minutes, reaching a peak concentration after approximately 90 minutes. This means that as you lie there, the essence of the plant is physically circulating through your heart, your liver, and your muscles, performing a kind of metabolic housekeeping that supports your body's natural recovery processes. At this very moment, imagine the way scent interacts with your memory, a phenomenon often called the Proustian effect, named after the writer Marcel Proust. This happens because the olfactory bulb is nestled right against the hippocampus. Scientists have found that olfactory-evoked memories are more emotionally charged and vivid than memories triggered by sight or sound. When you consistently use a specific scent like sandalwood or cedarwood for sleep, you are performing associative conditioning. Over time, your brain creates a high-speed neural pathway between that specific chemical signature and the state of rest. Eventually, the mere presence of a single molecule of cedrol can act as a master switch, turning off the stress of the external world and turning on the internal light of sleep. Deep within your cells, another process is unfolding. Consider the bergamot orange, or Citrus bergamia. In a 2015 study published in the journal Complementary Medicine Research, researchers found that inhaling bergamot essential oil for just 15 minutes significantly lowered salivary cortisol levels, a primary marker of stress, by an average of 24.3%. This isn't just a feeling of being relaxed, it is a measurable, quantifiable shift in your endocrine system. By reducing the amount of cortisol circulating in your veins, the bergamot molecules are allowing your heart rate variability to increase, which is a key indicator of a healthy, resilient nervous system. You might wonder how this relates to the bigger picture of your health. Think of your body as a garden, and these aromatic compounds as the specialized nutrients that help maintain the soil. Scientists have discovered that certain terpenes, like terpenin, 4, ol found in sweet marjoram and tea tree, can modulate the production of cytokines. These are the signaling proteins that control inflammation. By gently influencing these proteins, the science of aromatherapy helps to maintain the homeostasis of your body, the delicate balance where all your systems function in harmony. It is a slow, steady influence, much like the way gravity keeps the planets in their predictable, comforting orbits. Notice the way your chest rises and falls, a rhythmic movement that mirrors the pulsing of life across the planet. In the forests of Japan, the practice of Shinrin-yoku, or forest bathing, has been studied extensively for its impact on the human immune system. Trees release phytoncides, volatile organic compounds like alpha-pinene and limonin, to protect themselves from rotting and insects. When humans breathe these in, it has been shown to increase the activity of natural killer cells, a type of white blood cell that identifies and clears cellular debris and compromised cells. A 2007 study found that a 3-day forest trip increased NK cell activity by 50%, and this effect lasted for over 30 days. By bringing these forest molecules into your home, you are tapping into a global network of biological protection that has existed for millions of years. Consider the role of the 5-HT1A receptor, a specific type of serotonin receptor in the brain. Research published in the Journal of Natural Medicine suggests that linalool, the star molecule of lavender, interacts with these receptors to produce an anxiolytic or anxiety-reducing effect. This is the same receptor targeted by many pharmaceutical interventions, yet the plant does it through a subtle molecular dance. It's like the difference between someone pushing you into a seat and someone gently inviting you to sit down. The result is a profound sense of safety that allows the brain to release its grip on the waking world. What's happening now, as you descend into a profound stillness, is a synchronization of your internal rhythms. Scientists discovered that the scent of cedarwood, specifically the compound cedrol, has a significant effect on the autonomic nervous system. In clinical tests, cedrol was shown to increase parasympathetic activity, the rest and digest mode, while decreasing sympathetic activity, the fight or flight mode. This shift is accompanied by a decrease in heart rate and a stabilization of blood pressure. It is as if the molecules are singing a low-frequency hum that your heart recognizes and chooses to follow. Think about the molecule beta-caryophyllene, which is found in black pepper, cloves, and ylang-ylang. This is a unique sesquiterpene because it is also a dietary cannabinoid. It is one of the few plant compounds that can bind directly to the CB2 cannabinoid receptors in your body's endocannabinoid system. Unlike other compounds that affect the brain's CB1 receptors, beta-caryophyllene doesn't produce any high. Instead, it works quietly in the background to support a healthy inflammatory response and provide a sense of groundedness. It is a bridge between the world of plants and one of the most complex regulatory systems in the human body. In the silence of the night, Notice how the air seems to carry a weight of wisdom. This is not just poetic, it is rooted in the concept of neuroplasticity. The olfactory system is one of the only parts of the brain that exhibits neurogenesis, the birth of new neurons throughout adulthood. When you engage your sense of smell with complex, natural aromas, you are actually exercising your brain, keeping the neural pathways flexible and strong. A study conducted at the University of California, Irvine, showed that exposing seniors to a variety of scents for 2 hours every night over 6 months resulted in a 226% increase in cognitive performance compared to a control group. Your nose is a gateway to keeping your mind vibrant and young. Picture a single drop of rose otto oil once more. Beyond its 400 chemical components, it contains a specific molecule called damascenone. Even at incredibly low concentrations, parts per billion, it has a profound effect on human perception. This is a testament to the sensitivity of your biological equipment. You are designed to perceive the subtle, the minute, and the microscopic. In a world that is often loud and overwhelming, your sense of smell reminds you that the most powerful changes often happen in the quietest, most invisible ways. Scientists discovered that even the scent of lemon balm, or Melissa officinalis, can have long-term implications for brain health. It contains compounds that act as acetylcholinesterase inhibitors. This means they help prevent the breakdown of acetylcholine, a neurotransmitter that is essential for learning and memory. By supporting the levels of this chemical in your brain, the science of aromatherapy is helping to preserve the very fabric of your consciousness. It is a protective veil, woven from the molecules of the earth, draped over your mind as you prepare for the restoration of sleep. The bigger picture of this science is one of profound connection. You are not an island, you are a participant in a grand chemical exchange. The oxygen you breathe was exhaled by a plant, and the molecules that now calm your heart were manufactured by a leaf using the energy of a star 93 million miles away. This is the comforting void, a space where physics and biology meet to provide you with exactly what you need to rest. As you prepare to move into the next phase of this journey, let the weight of your body be a reminder of your place in the universe. You are governed by the same laws of motion and chemistry that move the galaxies. The molecules of lavender, cedar, and rose are your companions in this dark, quiet space. They are working on your behalf, modulating your receptors, clearing your cellular pathways, and preparing your mind for the deep, restorative work of the dream state. You are safe in the hands of science, and you are cradled by the wisdom of the natural world. There is nothing left to do but breathe and be, as the chemistry of peace continues its silent work within you. What's happening now is a subtle shift in your perception, as if the very air around you has gained a new dimension of depth and color. Imagine that you are looking through a high-powered lens, peering into the heart of a steam distillation unit where the alchemy of aromatherapy truly begins. Within this chamber, the temperature is carefully maintained at 100 degrees Celsius or 212 degrees Fahrenheit. As the steam rises through a bed of German chamomile flowers, something unexpected occurs. The plant contains a colorless precursor called matricin, but under the heat and pressure of the still, it undergoes a chemical transformation known as decarboxylation to become chamazulane. This molecule is a deep, vibrant ink blue, a color so intense it mirrors the deepest reaches of the interstellar medium. This is the why of its calming power. Chamazulene is a powerful anti-inflammatory agent, and its presence turns the clear vapor into a sapphire-colored liquid that holds the secret to cellular tranquility. Picture this. The blue color is the result of a specific arrangement of 10 pi electrons in a bicyclic structure. This arrangement allows the molecule to absorb light in the orange and yellow frequencies of the visible spectrum, reflecting only the serene blue back to your eyes. Notice how the color itself feels cooling, reflecting the scientific reality that this compound reduces heat and swelling in the body. Within a single drop of this oil, you are observing the laws of organic chemistry working in perfect harmony with your biological needs. At this very moment, we should consider how scientists verify the purity of these complex liquids. They use a technique called gas chromatography mass spectrometry, or GC-MS. Imagine a tiny coiled tube about 30 to 60 meters long and only 0.25 millimeters in diameter, coated with a specialized polymer. This is the racetrack for molecules. When a sample of essential oil is injected, it is vaporized and pushed through this tube by an inert gas like helium. Because every molecule has a different mass and a different level of stickiness or affinity for the polymer, they emerge at the other end at different times. This process, which earned Archer Martin and Richard Singh the Nobel Prize in 1952, allows us to see every single chemical component, from the lightest alpha-pinene to the heaviest sesquiterpenol, with a precision that borders on the miraculous. Deep within this analysis, we find the fingerprint of the plant. A high-quality lavender oil will typically contain between 25% and 45% linalool acetate and 25% to 38% linalool. If these percentages are off by even a few points, the oil's ability to soothe your nervous system changes. This is because the molecules operate as a synergistic collective. Think of the chemical profile of an oil as a kaleidoscope. Each time the plant is harvested under different conditions, perhaps a colder spring or a sunnier summer, the rotation of the kaleidoscope changes the pattern of its molecules. Yet, the core geometry remains, providing a consistent signal to your brain's receptors. Observe the precision of the boiling points of these compounds. Linalool, the primary sedative in lavender, has a boiling point of 198 degrees Celsius or 388 degrees Fahrenheit. In contrast, a lighter monoterpene like myrcene, found in lemongrass, boils at only 167 degrees Celsius. This difference in temperature sensitivity is what dictates the texture of the scent you experience. Notice how the lighter notes feel thinner and more ethereal as they enter your nostrils, while the heavier molecules feel thick and velvety. This is the physical reality of vapor pressure. At room temperature, molecules with a high vapor pressure above 0.01 mmHg are constantly leaping off the surface of the oil and into the comforting void of your room, seeking a path to your olfactory neurons. Scientists discovered that our sensitivity to these molecules is almost beyond comprehension. Consider the concept of the odor detection threshold, or ODT. For certain compounds, like beta-ionone found in violets and roses, the human nose can detect its presence at a concentration as low as 0.007 parts per billion. To put this in perspective, that is like detecting a single drop of liquid in 20 Olympic-sized swimming pools. Your body is a finely tuned instrument of chemical detection, capable of sensing the arrival of a single botanical messenger across a vast expanse of empty space. This is why you don't need a large amount of oil to feel its effects. Your biology is designed to respond to the whisper of a molecule, not just a shout. What's happening now is a manifestation of van der Waals forces. These are the weak, flickering attractions between molecules that allow them to cluster together as a liquid or disperse as a gas. As the oil warms against your skin or in a diffuser, the kinetic energy of the heat overcomes these subtle forces, liberating the molecules into the air. Picture them as a cloud of tiny, spinning satellites, each one held together by covalent bonds, the sharing of electrons between carbon and hydrogen atoms. Most monoterpenes follow the formula C10H16, a perfect stable geometry of 10 carbon atoms and 16 hydrogen atoms. This structural stability is what allows these molecules to travel through the air without breaking apart, delivering their message of rest intact to your brain. Consider the role of optical rotation, a phenomenon measured using a device called a polarimeter. When a beam of polarized light passes through an essential oil, the chiral molecules, the ones with handedness, actually rotate the light either to the left or the right. For example, the limonene found in oranges is almost always dextrorotatory, rotating light to the right, and it carries a bright, uplifting chemical signature. Its mirror image, levorotatory limonene, found in pine needles, smells more like turpentine and has a completely different effect on your mood. At this very moment, your nose is acting as a biological polarimeter, instantly identifying the spin of the molecules and translating that physics into a feeling of comfort or clarity. Notice the temperature of your own breath as it interacts with these volatile compounds. When you inhale, the air is warmed by your nasal passages to nearly your body's core temperature of 37 degrees Celsius. This extra heat provides the latent heat of vaporization required for the molecules to stay in a gaseous state as they travel deep into your lungs. Once they reach the alveoli, the tiny air sacs in your lungs that have a combined surface area of about 70 square meters, or the size of a small apartment, they cross into your bloodstream with ease. This is because the molecules are non-polar and small enough to slip through the lipid membranes of your cells like ghosts passing through a wall. Scientists discovered that even the color of the bottles we use is rooted in the physics of light. Essential oils are often stored in violet or dark amber glass, because these colors block the most damaging wavelengths of the solar spectrum. Ultraviolet light, specifically UVA and UVB rays, between 290 and 400 nanometers, has enough energy to trigger free radical reactions within the oil. These reactions can turn a therapeutic ester into a harsh acid. By filtering out these high-frequency photons, the glass ensures that the oil remains in a state of low entropy, a state of organized, calm potential, waiting for you to release it. Think about the specific gravity of the oils you might be smelling. While most essential oils are lighter than water, there are a few notable exceptions that behave with a different kind of gravity. Oils like vetiver, clove, and cinnamon bark have a specific gravity greater than 1. If you were to drop them into water, they would sink to the bottom like smooth, heavy stones. This physical density mirrors their aromatic profile. They are the base notes of the forest, moving slowly and lingering long after the lighter citrus oils have vanished. They provide the foundation of your sensory experience, a heavy, grounding presence that helps anchor your mind to the physical world. What is happening now is an exploration of the why of plant life. Plants do not create these complex oils for our benefit. They are secondary metabolites used for survival. A plant might produce a specific terpene to protect itself from the heat of the sun or to prevent moisture loss in a drought. During photosynthesis, a plant absorbs photons at specific wavelengths, primarily 430 nanometers blue and 660 nanometers red. It then uses this energy to convert carbon dioxide and water into glucose, and eventually into the complex isoprenoid pathways that create essential oils. When you inhale these scents, you are literally breathing in the processed energy of a star, converted by a plant into a form that your human nervous system can understand. Imagine a single 1 milliliter drop of oil. Within that tiny volume, there are approximately 10 to the 20th power molecules. That is a 1 followed by 20 zeros, a number so vast it exceeds the number of stars in our observable galaxy. As you lie there, you are submerged in a sea of billions of potential interactions. Each inhale brings millions of these stars into your internal universe, where they navigate the currents of your blood and the pathways of your nerves. They are clearing cellular debris and restoring the intracellular balance of your tissues, working with the silent, rhythmic efficiency of the cosmos. Notice the way your thoughts have slowed to match the diffusion rate of these heavy bass notes. The air is thick with the scent of molecules that have existed for millions of years in various forms, recycled by the Earth's great cycles of growth and decay. You are part of this cycle. Your biology is not a separate entity, but a localized expression of the same chemistry that builds trees and stars. As the molecules of the oil find their locks in your brain, and the receptors send their final signals of the day, you are becoming as heavy and as stable as a sesquiterpene molecule, drifting toward a state of perfect equilibrium. The world of sound and light is fading, replaced by this invisible chemical landscape. There is a profound beauty in the physics of this moment, in the way heat liberation leads to molecular flight, and how that flight ends in the quiet sanctuary of your mind. We have traveled through the still, the laboratory, and the microscopic structures of the leaf. We have seen the blue of the chamomile and felt the weight of the vetiver. Now, as we move toward the final part of our journey, let these facts remain as a quiet background hum, a scientific lullaby that assures you that everything in the universe is unfolding exactly as it should. The void is not empty, it is full of the breath of the earth, and it is carrying you home. Our observation of the external world is now beginning to draw to a gentle, quiet conclusion, as the focus shifts from the microscopic lab of the plant to the internal sanctuary of your own biology. At this stage of the process, your body is moving through the final transition toward the state of unconsciousness. The air in your room, still saturated with the remnants of aromatic molecules, is becoming a backdrop for your descent into rest. What is happening now is a series of precisely timed biological events, a step-by-step shutdown of the waking mind that has been guided by the chemical messengers we have studied. As you lie still, notice how the scent that was so prominent minutes ago has started to fade. This is a scientific process known as olfactory fatigue, or habituation. Within approximately 2 to 10 minutes of continuous exposure to a scent, your olfactory sensory neurons stop sending high-frequency signals to the brain. This is not a failure of your senses, but a sophisticated filtering mechanism. Your brain has decided that these molecules, whether they are the esters from lavender or the oxides from eucalyptus, are safe and constant. By muting the scent, your nervous system frees up resources, allowing your focus to move inward. It is a sign that the chemical invitation to rest has been accepted. At this very moment, your brain is transitioning from the alpha waves of relaxed wakefulness to the theta waves of stage 1 non-rapid eye movement sleep, or NREM. This initial stage of sleep typically lasts between 1 and 7 minutes. During this window, your heart rate, which may have been at 70 or 80 beats per minute, begins to slow and become more rhythmic. Scientists have observed that the inhalation of linalool can facilitate this transition by increasing the power of these theta waves, which oscillate at a frequency of 4 to 8 hertzes. You are moving across the threshold, leaving the world of active thought and entering the world of restorative biology. Deep within the center of your brain, the pineal gland is responding to the dimming of light and the presence of calming aromatic signals. This gland, a pinecone-shaped structure roughly 7.2 millimeters in diameter, is the producer of melatonin. Melatonin is synthesized from the neurotransmitter serotonin, a molecule with the formula C10H12N20. The presence of scents like sweet marjoram has been shown in clinical studies to support the parasympathetic nervous system, creating the ideal physiological environment for this hormonal shift. As melatonin levels rise in your bloodstream, your core body temperature begins a slow, deliberate decline, dropping by about 1 to 2 degrees Celsius to conserve energy for the night. Consider the journey of the carbon atoms that make up the very molecules you've been breathing. These atoms, which account for roughly 18.5% of your total body mass, were not created on Earth. They were forged billions of years ago in the hearts of ancient red giant stars through a process called the triple alpha reaction. At temperatures exceeding 100 million Kelvin, 3 helium nuclei fused together to create a single carbon nucleus. When those stars reached the end of their life cycles and collapsed, they scattered these elements across the comforting void. Every molecule of the essential oils you use, and every cell in your lungs that absorbs them, is a piece of cosmic history. You are literally breathing the recycled dust of the stars. What's happening now is a gradual handoff between the chemical work of the plants and the restorative work of your own system. The linalool and linaloyl acetate molecules that entered your bloodstream earlier are now being metabolized. For most terpene alcohols, the half-life in the human body is between 45 and 90 minutes. This means that as you submerge into sleep, these molecules are performing their final tasks, interacting with GABA-A receptors to ensure the neural pathways remain quiet. They are the scaffolding for your rest, holding the structure of your serenity in place until your own internal sleep mechanisms take over completely. As your breath becomes even more shallow and slow, typically reaching a resting rate of 12 to 15 breaths per minute, your brain enters stage 2 NREM sleep. This is where sleep spindles occur, bursts of brain activity that last about half a second and occur at a frequency of 11 to 16 hertzes. These spindles are thought to be the brain's way of disconnecting from sensory input, ensuring that outside noises or smells do not wake you. Even here, the heavy bass notes of your aromatherapy, like the sesquiterpenes in vetiver, provide a grounding chemical, white noise that helps maintain this protective barrier. Notice the feeling of weightlessness in your limbs. This is the result of your muscles entering a state of decreased tonus. While you are anchored by the Earth's gravity, a constant force of 9.807 meters per second squared, your perception of that weight is softening. You are like a planet settling into a stable orbit, no longer fighting the pull of the sun, but surrendering to the elegant curve of space-time. The iron in your blood, which has an atomic number of 26 and was forged in the explosive deaths of massive stars known as Type II supernovae, is now circulating with a quiet, steady rhythm. Scientists have discovered that during this phase of the night, your brain's glymphatic system becomes 10 times more active than during the day. This system is a specialized network that clears metabolic byproducts from the central nervous system. Using the pressure of cerebrospinal fluid, it flushes out cellular debris, such as amyloid beta proteins, that accumulate while you are awake. Think of it as a deep, molecular tide that rises every night, refreshing the landscapes of your mind. The calming scents you chose help signal the brain to begin this vital housekeeping, ensuring you wake with a clear and restored consciousness. Now, as you move toward the deepest levels of rest, the brain begins to produce delta waves. These are the slowest, highest amplitude brain waves, with a frequency of 0.5 to 4 Hz. This is the stage of sleep where the body performs its most significant physical repairs. Growth hormone is released from the pituitary gland, stimulating protein synthesis and cell regeneration. In this state, you are as far from the waking world as a distant moon is from its primary planet. You are in the heart of the void, a place of pure restoration and silence. At this stage of the process, the aromatic molecules have done their work. The citrus notes have long since evaporated, and even the heavy resins are now only a whisper in the air. The chemical dialogue is complete. Your body has taken the information provided by the plants, the signals of safety, the messages of stillness, the reminders of the forest, and integrated them into your own cellular rhythm. You are no longer just observing the science of aromatherapy. You are the embodiment of it. You are a biological system in a state of perfect homeostatic equilibrium. Consider the nitrogen that makes up 78% of the air you are breathing. This nitrogen is essential for the amino acids that build your muscles and the DNA that carries your blueprints. Like carbon and iron, this nitrogen was born in the intense heat of stellar furnaces. You are a walking, breathing laboratory of the cosmos, a place where the laws of physics have become conscious. As you rest, remember that the universe is not something you are in, but something you are a part of. The same gravity that holds the galaxies together is the gravity that keeps you safe in your bed. As the light of the day remains a distant memory and the warmth of your sleep becomes a total embrace, let these affirmations of rest move through your mind with the slow rotation of the stars. I am made of the same elements as the silent nebulae. My breath is a rhythmic exchange with the ancient atmosphere. My nervous system is a masterpiece of chemical balance. I am surrendering the weight of the day to the pull of the earth. My mind is a quiet vessel for the restoration of the night. Every cell in my body is vibrating at the frequency of peace. I am safe in the vast, comforting architecture of the universe. The molecules of the earth have guided me home to myself. I am sinking into the velvet dark of the restorative void. My rest is deep, my rest is certain, my rest is complete. The journey through the science of scent is over. The distillation is finished. The molecules have found their locks. The laboratory of the mind is dimming its lights. The temperature is perfect. The air is still. The clockwork of the cosmos continues its silent, beautiful dance, but you no longer need to watch it. You are part of the dance now, moving in the slow, lightless circles of the deepest sleep. The carbon, the nitrogen, the iron, and the oxygen are all at rest within you. The chemistry of peace has reached its final, most stable state. There is nothing left to observe, nothing left to learn, and nothing left to do but exist in this perfect, weightless silence. You are stardust returning to the quiet of the night. You are the universe dreaming of itself. Good night.